Alright, so we just got done looking at these nice, pretty mole-to-mole stoichiometry conversions.
Those were nice.
Those were really nice. We just pulled things out of our balanced equation. The problem is, there is not a balance in this world where you can just put your substance on it and it will tell you how many moles. There's no way we can measure that directly.
That's too bad.
But, so I can measure mass, but if I've got 1 gram of oxygen and 1 gram of hydrogen, do I have any idea how that's going to mix together to make some amount of water?
No, not really.
No, because we looked at how our particles interact. So when we were originally balancing, we talked about it takes 2 molecules of 2 molecules of hydrogen gas to give us, plus 1 mole of oxygen gas gives us 2 molecules of water.
Right.
And we looked at our mole ratios last time, so we could do the same thing with moles, but we can't do the same thing with mass, because masses don't compare directly.
Okay.
So we can compare moles of one substance to moles of another. We just did that in the last video.
Right, when we were pulling those we pulled the mole ratios from the equation.
So anytime we're doing a stoichiometry problem, we're going to have to go through moles. No matter what we're starting with, no matter what we're trying to get to, we're going to have to go through moles. And we already know the math we need to get us there. So when we're doing stoichiometry, we're doing dimensional analysis still, we're doing unit conversions, but there's actually only 2 unit conversions you can ever use to do stoichiometry.
That's actually kind of nice.
It is really nice. You've got 2 choices. We know from the previous video that if we want to know moles of one substance to moles of another, then we're going to get that from our balanced equation.
Okay.
What we haven't used yet, but we really have, is that if we want to get from mass to moles, or from moles to mass, we're going to use
molar mass.
Molar mass, which we learned about back in 7a. Because we know the definition of molar mass is that it's the mass of 1 mole of a substance. And how do we find the mass of 1 mole of a substance?
So we look at the mass for the element on the periodic table. And then if we've got more than one, if we've got a compound, we take the mass of all of the elements and then we add them all together.
Okay. So we've done molar mass. We know molar mass, and we've even used molar mass to go from mass to moles, or moles to mass. We're just going to have... So we're taking what we did in the last video and combining it with what we already did in 7a. This is not new math.
Okay.
This is just combining a couple parts together. So it should be really straightforward. So just be confident and let's try some.
Okay.
Alright, so remember, stoichiometry is just dimensional analysis, and this is all conversions we've done before. So we're going to still start with
the given, which is 2.02 grams of hydrogen.
And then figuring out what we
want is moles of H2O.
All right.
Okay, so let's go ahead and set up the tracks. We start with 2.02 grams of hydrogen.
And then we know we're going to
need grams of hydrogen on the bottom.
And we know that we're always going to have to get to
moles. So that means this is going to be moles.
This is still moles of H2. Okay. If you've got grams on one side and moles on the other, they've got to be the same substance, because the comparison we know for grams and moles is molar mass, which is the mass of how many moles?
1 mole.
1 mole. So 1 mole is going to go on top.
And the molar mass of H2,
we look at the periodic table and then we double it.
So 1.008 times 2 is...
We're going to round it to 2.02.
Okay.
2 decimal places is okay for molar mass.
2.02.
All right. So we've got grams of H2 and grams of H2. That leaves us with moles of H2. Is that what we want?
We want moles of H2O. So we got to keep going.
We got to keep going.
Okay.
And if we think back to our last video, how did we get from moles of one substance to moles of another?
We had to use the mole ratios.
From our
balanced equation.
So let's write down our balanced equation real quick.
Okay.
So remember, to get water, and we've seen this before, we have 2H2 plus 1O2 gives us 2H2O.
2H2. Okay, so if I go back to the railroad tracks, I've got moles of H2 on the bottom.
And I want moles.
I want moles of water on
Okay.
the top. H2O.
And we just pull those numbers
Okay, so
from our balanced equation.
there's the number for the H2, and there's the number for the H2O.
Okay.
So when we do this, we multiply those.
And we're also going to multiply our numbers that are next to each other
okay,
on
they're
the
next to each other
bottom.
down there.
So we're putting this in the calculator. We should put 2.02
2.02
times 2
times 2
divided by, and then put in parentheses 2.02
2.02
times 2 close parentheses, because otherwise order of operations is going to do bad things to you.
And then
All
we
right.
do that.
So we do that, and what we find out is we actually
4 divided by 4.04 is
1.
1.
So we're going to make 1 mole of water if we start with 2.02 grams of hydrogen
I
gas.
see what you did
So see,
there.
we haven't really made anything more complicated. We've just taken a couple things we already know and put them together.
So this is kind of similar to the last time when we did molar mass, we had to do particles.
Right.
Right.
But hey, guess what? The particles are not going to show up anymore. Don't try to worry about particles. Ignore particles, purge particles from your mind.
Because all we have to worry about is mole ratio and molar mass.
Right. Stoichiometry, mole ratio, molar
Okay.
mass, those are your choices.
That's something I can handle.
All right. So, important things to remember before we set you loose on your guided practice. You're going to use your molar mass if you're trying to get between what?
Moles and grams.
Or backwards, grams and moles.
Okay, that makes sense.
All right, we're going to use our mole ratio if we're trying to do what?
If we want to convert between different substances.
Right, because the only way we can compare two different substances is by knowing their ratios from a balanced equation.
All right.
All right. And if you've noticed in all this stuff we do we have to change our math whether if one of our substances is a reactant or one of our substances is a product, or if they're both products or if they're both reactants?
No, we ended up doing it all this. I mean, it was all the same math. It was all the same
Right.
setup.
You don't care where in the equation it is, you're still going to use your mole ratios. And no matter what, no matter where you start, no matter where you're trying to get,
We have to go through the moles.
right, because moles can be directly compared. Nothing else can. If you do a stoichiometry problem and you have not ended up in moles at any point in time, something has gone wrong. You must go through moles. All right.
All right.
So, try the guided practice. Remember, it's just taking parts you already know and putting them together. When you get stuck or when you get done, come back and see us and see how you did.
Alrighty.